Alright, this is section 5.2. They ask us to use the definition of logs to rewrite this. So remember, this is 4 equals log base 2 of 16. So you remember logarithms equal the exponent, so that's got to be your exponent. And you know this is your base because you read it as log base 2. So base 2 raised to the exponent 4 equals whatever that third number is right there, 16. So 4, base 4 raised to the 1/2 equals 2. 3, base 3 raised to the exponent -2 equals 1/9. Okay, and now they ask you to solve these, ask you to write them in exponential form. So it's 3 raised to the 4th equals x. Okay, so 3 raised to the 4 equals x. 3 raised to the 4 equals x, and that's 3 to the 4th is 81. 25 to the 1/2 equals x. 1/2 is the same thing as square root, and so that's just 5. Notice it's not plus or minus 5 because the square root is already in the problem when you have that 1/2 there. It's really already a square root. It wasn't introduced into the problem. Number 9, 7 raised to the 2 equals 3x plus 1. So it's 49 equals this, and the rest of that's just algebra, right? You can solve that. 2 raised to the 2 equals 4x minus 7. Or excuse me, 10. When there's no base written here, it's assumed to be 10. 10 to the 2 equals 4x minus 7. So it's 100 equals 4x minus 7. Add 7, divide by 4, you got your answer. 13, that's log base e to the 2.2 equals 2x plus 5. Okay, if you want an exact answer, you leave this as e to the 2.2, and then you subtract 5, then you divide by 2, and this is the exact answer. It's ugly, but it's the exact answer. This is the approximate answer. Now they want you to rewrite this using logarithms. So log base 2 of 32 equals 5. Log base 2 of 32 equals the exponent 5. Log base 4 of 1/4 equals the exponent -1. Log base e of 0.55 equals the exponent 3x plus 5. So now that's just ln of 0.55. Subtract 5, divide by 3. Now that's the exact answer right there, and that's the approximate answer. 21, they want you to rewrite this using log change of base formula, so the x goes above and the 3 goes below, and that's one way you can graph this, or you can just graph this guy. 3 to the y equals x, and you can fill things in using the graph it by filling in points. But in this case you want to pick y values and then figure out what the x values are. Once you pick a y value of maybe 2, you know 3 to the 2 is 9. 1, 3 to the 1 equals 3. 3 to the 0 equals 1, and so on. And so this is what it looks like. Now if you also graph this on your calculator, you get the same picture. 23, y equals ln of x, or e to the y equals x. And again, you pick your y values and you figure it out on your calculator what e to the 1, 2, 3 is, e to the -1, 2, and 3 is, and so on. 27, log base 3 of 27 equals, they want you to write this, solve this without using your calculator. So the trick is to use the use this rule, rule number 3. If these two numbers match, the base and this number are the same, your answer is just the exponent. Okay? So you want to write this with a 3 because your base is 3. So 3 cubed. So now those guys match, so your answer is just the exponent 3. Now this part here, we know that log base a of a is just 1. So log base 3 of 3 is just 1. And 3 times 1 is 3. Log base 5 of 1/5, well that's 5 to the -1. And so that whole thing just equals -1. You don't have to show all these extra steps. You can immediately go to -1 if you want. Now 29 says f of x equals ln of x, so then they ask you what's f of e to the x. Well, that's ln e to the x. Remember, ln means log base e. And now log base e of e to the x is just x. F of x equals e to the x, and they plug in ln of 3, so they're asking you e to the ln of 3. Well, that's e to the log base e of 3. And if you look over here, if these two match, the answer is just, well, excuse me, if you look here, the e and the e match, the answer is just the exponent, or the third number there, x. Just like over here, a raised to the log base a of x equals just x. If these two guys match, then the answer is just this third guy. Alright, 35, what they want you to do is break things up and figure out the actual value, knowing that they give you these values here. They tell you what log base a of x is, log base a of y is, but they don't tell you log base a of x times y. Well, you have to use rule 7. Two things multiplied equals the sum of the logs. So you break this up into addition of two logs. And log base a of x is 3.1, log base a of y is 1.8, and you add them together and you get your answer. Same thing here. Log base a of x over z is log base a of x, subtract log base a of z. Division becomes subtraction, just like multiplication becomes addition. And this guy is 3.1, and up here this guy is 2.7, and when you subtract them you get 0.4. Alright, this one, log base a of x to the fourth, well, you can bring the 4 out front. Okay, and log base a of x, do we know what that is? Yes, we know log base a of x is 3.1, so 3.1 times 4 is 12.4. Alright, now this one, we got to get rid of that square root. So it's first power and second root, so you write it as 1/2 power. And then you can use rule 9. Rule 9 allows you to bring the exponent out front. C is up in the exponent, so you can bring it out front right there. So you bring it out front, and now this part becomes 1.8, and then multiply it by 1/2, and you get 0.9. Okay, now these they want you to break it up into as many logarithms as you can. So this is log x over log x plus 1, or log x over x plus 1, which is division, will become subtraction of these two separate logs. Now you can't go any further with that because we don't have a rule for breaking up addition. We only have a rule for breaking up division and multiplication. Now in this one they want you to go in the other direction, so write these two logs as 1. So subtraction becomes division. Now if you're going to bring things together, one of the rules is you can't have any numbers in front. Notice this is just plain log a of ab. Log base a of a plus log base a of b. There's no numbers in front of any of these. Same here, there's no number in front, no number in front, no number in front. So if you start out with something that has a number in front like 1/2, you got to bring it into the exponent and get rid of that number that's in front. Remember earlier we had a 1/2 in the exponent and we brought it out front. Well, you can go in the other direction. You can bring it into the exponent. And that helps us here because then that gives you a square root there, and now you got two things that are added becomes the two things multiplied. And this one, same idea, the 1/3 goes up there and it becomes the third root, and now the two things are subtracted so they become divided. And 51, they want you to use change of base, so this number goes above and this number goes below. And then you ask your calculator what that is. This number goes above and this one goes below, and you get that number. This one goes above, this one goes below, and you get that number. Same thing here. Alright. And 71, they ask you to find out what t is, and they tell you all of the numbers that you need to know except for t. It's question 71. Yep. So you've got this guy here, and the only thing you don't know is t. Well, this is 8 over 400, which is 0.02. And so it's 1.02 raised to the 4t equals 2. So it's log base 1.2 of 2 equals 4t. So that's log 2 over log 1.02, which is this guy, and divided by 4 and you get 8.75, and that's your interest rate. That's the interest rate that you get from calculating this problem out.